Hey everybody, happy Friday. Let's go through that second set of calculations. It's 8, 9, 10, 11, well, 8 to 15 on the series circuit calculations 1. We're going to do the exact same process we did before. Remember, first we're going to find the totals, and then we find individual. Okay, and the equation we use for all this stuff is also known as Ohm's law. So voltage is equal to current times resistance. Okay, what is our total voltage? Total voltage is just add them up. So it's 9 volts plus 9 volts equals 18 volts. That is our V total. Next up, what is our total resistance? Total resistance of a series circuit is going to be simply the sum of the resistance. In other words, our equivalent resistance for a series circuit, if we were to take these three resistors and cut it down to 1, would just be the sum. So we're going to take 1 plus 2 plus, and that was a 6 ohm on the bottom, giving us 9 ohms. Now that we have those two, we can use the total voltage and the total resistance to calculate our total current. Rearrange Ohm's law to get voltage divided by resistance. So we're looking at 18 volts divided by 9 ohms gives us 2 amps. Now, number 11. If one of the batteries is removed, how would the current change? Well, if the voltage goes down, voltage decreases, so does the current, and this happens because it is directly related. Okay. More specifically for this, because we know how much the voltage is and we know how much the current is, if our voltage is cut in half, 1/2 our voltage will be proportional to 1/2 our current. So that means the new current would be 1 amp. But that's not what we're going to use for the rest of these problems. That was just kind of a test question. In the same vein, if we were to decrease the resistors, okay, if we decrease our resistors, that means our current would have to increase. So if this goes down, current has to go up because current and resistance, current is inversely proportional to resistance. One goes up, the other is going to go down. So if our resistance goes up, our current will decrease. Okay. Number 13. Now that we have our totals from 8, 9, and 10, we're going to calculate the voltage used by each resistor. So again, I'm going to also show you how the voltage changes across each one of these resistors. We've got 18 volts coming in. So our voltage across 1 ohm resistor, we're just going to use voltage equals IR is current times resistance. So we have 2 amps times 1 ohm gives us 2 volts. So as that 18 volts comes into the 1 ohm resistor, 2 volts is changed to another form of energy, and 16 volts comes the other side. That 16 volts is going to turn the corner, and it's going to come into the 2 ohms. That 2 ohms is going to change the voltage. Just figure out how much. So the voltage at the 2 ohm resistor, this was the 1 ohm, The voltage at the 2 ohm resistor is equal to the current times the resistance of the 2 ohm. So it is 2 times 2, giving us 4 volts. So if 16 volts comes in, 4 volts gets changed, 12 volts will come out, and it's going to turn the corner. 12 volts is going to come into that 6 ohm resistor. Using our same equation, the voltage across the 6 ohm resistor is equal to the current, which is the same everywhere, and our resistance across our 6 ohm resistor. So it's 2 times 6. That gives us 12 volts. 12 volts comes in, 12 volts gets changed, 0 volts comes out, which is exactly what you want. Now, 14, we're adding a new equation, how to find power. So we got our voltage, we have our current, we have our resistance. To determine the power used by a circuit, you're going to use power is equal to the voltage, the push, times the amount of flow, times the current. So voltage times current will give you the amount of power. So calculating that one, our total voltage was 18 volts times our total current, which is 2 amps, giving us 36 watts. Notice it is the same unit as the unit for power from our energy unit. Number 15, we're going to use that same voltage, the same total voltage, it wants us to find the amount of power used by the 6 ohm resistor. So the power used by the 6 ohm resistor, here's the same basic equation, is the voltage times current, except if we're going to talk about the power for the 6 ohm resistor, we're going to use the voltage from the 6 ohm resistor. So that becomes 12 volts times 2 amps, giving us 24 watts. And that covers it. Let me know if you have any questions through comments or in class.